All right, in section 8.4, we're going to look at number 10. So, is fishing better from a boat or from the shore? Pyramid Lake is located on the Paiute Indian Reservation in Nevada. Presidents, movie stars, and people who just want to catch fish go to Pyramid Lake for really large cutthroat trout. Let row B represent hours per fish caught fishing from the shore, and let row A represent hours per fish caught using a boat. So the following data are paired by month from October through April. Use a 1% level of significance to test if there's a difference in the population mean hours per fish caught using a boat compared with fish from the shore. All right, so in this section, we're looking at paired or matched data. Okay, so if we have the sample size that is from the boat, is there a relation or something connecting it to the shore? Well, they're both collected during the month of October, so that month is pairing these first observations together. When we do section 8.5, they will be independent samples. There'll be nothing, like if they just collected the hours per fish caught using a boat, they just 1, 2, 3, 4, 5, 6, 7. They just had 6 random numbers they collected at any time and 6 random ones from a boat. They weren't connected in any way. Those would be independent samples. But because these are connected, that they were both observed in October, that makes them matched or paired data. So oftentimes with your matched and paired data, you'll notice in your homework, there's another row, just like in this one, that's connecting those together. Okay, so you do want to watch Dr. Mosley's video on the lecture notes for this section to make sure you understand the difference there. Okay, so when we use matched or paired data, when we set up the null hypothesis and the alternative hypothesis, what we are now testing is really the average distance. This is called mu d. It is really representative of what the difference would be in the two averages. But we represent that as mu d. Okay? So in the null, we're always assuming that there's no difference. In the alternative, it depends on what we're testing. We want to say, is one larger than the other? In this particular problem, it just tests if there is a difference. So it's not asking us if the shore catches more fish or the boat catches more fish, if one of these are larger. This is just asking us if they're different. So to determine that, though, I'm going to write, okay, B is shore. I'm going to write beside it, the second row is A is boat. Okay, so if I was wanting to know if shore was bigger than boat, I would put a greater than sign. If I was wanting to know if shore is less than boat, I'd put a less than. But here I just want to know if it's not different. So whichever, you want to write them side by side like this to determine what the alternative is going to be. That's the easiest way to do these. So this would be mu d not equal to 0. You have to be really careful on how you set up this alternative. All right, now I'll show you how to put those in the calculator. Okay. So we go and we're going to put these in our list. So again, we do stat, edit. I'm going to put the first row in L1, and I don't have these in here yet, so you can do this with me. May lengthen my video a little bit. All right, now the trick to these is we have to create a third column because what we're testing and we're using in our test statistics is the difference in these observations. Okay, ready for this? So you want to arrow up so your cursor's over the top, over that L3. And if you watch right here, we're going to do a formula. I'm going to say L1, remember above the 1 key, second L1. See how it says L1? Minus second L2. So that's above the 2 key. So right now I have this formula that's going to say Create a list of data where you're subtracting 1.6 minus 1.5. Should be 0.1, right? 1.8 minus 0.4. 1.4 should be 0.4. So all you have to do is type that formula in when you're over the top, hit enter, and it should do it, 0.1, 0.4. It just subtracted all these numbers. Okay? So now to get our test statistic, we're just doing a t-test on this third column. And these are always a t-test, no matter what, on the paired differences. Anytime you use a mu-d, you're going to use a t-test on L3. So t-test on L3. That's the key here, okay? Let's do second quit. Let's do stat, test. I'm just going to go to two tests. Okay, none of these two sample ones, these are all for independent. We're going to go to t-tests, okay? Always choose data. Mu naught in these tests is always going to be 0. But now our list, we want to choose L3 above the 3 key. Very important, t-test on L3. Frequency is 1. We look at the alternative. We're doing not equal to. And hit calculate. And that is our test statistic, 2.08. Okay, we still need to do step 3, and we'll skip down to step 4 and write my p-value. Where's my p-value? 0.0822. All right, now we do 3, 4, and 5 the way we've been doing. Okay, I'm going to draw my critical region. We have to draw now. Right-tailed, left-tailed, or two-tailed, this is not equal to, so we want to do a two-tailed test. Okay, that means we're going to have a rejection region in both tails, meaning we have 2 critical values. They're going to be the same, one positive, one negative. Okay, middle 0. All right, so we're going to use our table to look up that critical value. We need our degrees of freedom anytime we're doing a t-test. Since there were 7 pairs, we do 7 minus 1, or 6. Alpha was 0.01 this time, so on our t-table, we have a two-tailed test. Go over all the way over to 0.01. And we're going to go down to 6. 3.707. So I have a positive 3.707 and a negative 3.707. Make sense? So where is my test statistic? Now that I have my critical region, where does this test statistic fall? Well, remember this is 0. Does 2.08 fall between these two or in the tails? It's positive, so it's over here, right? But it's not larger than 3.707, so it's actually somewhere right here, approximately, right? So my test statistic has to fall in the tails for me to reject. Remember, these are the rejection regions. Since it does not, falls in the middle here, our decision is do not reject H0. Make sense? For step 4, our criteria is the same as it has always been. We're going to reject H0 if the p-value is less than alpha. This is why the p-value is so powerful. It stays the same no matter what type of test, whether it's right-tailed, left-tailed, two-tailed, z-test, t-test, f-test, ANOVA. This is always the same. That's why it's very powerful. Okay? So our p-value is 0.0822. The question is that less than alpha 0.01? Remember how to compare these? Put the zeros on. Think of them as numbers. Is 822 less than 100? Absolutely not. Right? Since we said no, we're going to say do not reject H0, which again should match up here, right? So then our decision is at the 1% level of significance. Remember here we say we do or do not. Of course, we did not reject, so we do not have enough statistical evidence to conclude that, I go back to my problem. I was testing the significance to test if there was a difference. So to conclude that there is a difference in the population mean hours per fish caught using a boat compared with fish from the store or shore. Sorry. Okay, make sure you write that all the way out, because when you do my test, you're going to have to do that. I would again do the whole 5 steps and then try to answer the questions within one at a time.